Okay, let's dive into this explainer and tackle one of the most notoriously tricky data engineering interview questions out there. If you work with Apache Spark, you already know that diagnosing failures in a distributed system, well, it's kind of like an art form. So today, we're going to master that art. We're looking exactly at how to troubleshoot persistent retries right inside the Spark UI. This is absolutely crucial for any of you professionals or students out there prepping for your next big technical interview. Picture this. You're sitting in the hot seat. The interviewer leans in, looks you right in the eye, and drops this exact question. Your Spark UI shows all stages completed except one, and that one stage just keeps retrying endlessly. How do you investigate? So how do you prove to them that you aren't just guessing? How do you show them you're a true data detective? To nail this, we'll use the data detective framework. We're going to cover the scenario, the three-step investigation, the prime suspects, other common causes, key metrics, and finally, the perfect interview answer. All right, let's kick things off with section 1, the scenario and the mindset. Here's the deal. A good answer has to follow a logical troubleshooting process rather than just jumping straight to one cause. It is incredibly tempting to just blurt out, oh, it's a memory issue, or it's a bad join. But interviewers, they don't just want a lucky guess. They really want to see your methodology. Treat this literally like a crime scene. You need a logical path to isolate the issue, which proves you can handle absolutely any bug they throw at you, not just the ones you've memorized. Moving right along to section 2, the three-step investigation. This is a troubleshooting flow you can easily execute even under pressure. Step 1, understand the problem. Step 2, open the Spark UI. And step 3, read the Executor logs. Delivering this methodical, funneled approach in an interview shows you know exactly how to trace a failure right from the top down. Now, before jumping to conclusions, you've got to ask yourself, is the entire stage failing, or is it just one tiny task inside that stage holding everything up? Did Spark finally fail after hitting its maximum retries? You verify this by opening up the Spark UI and checking out the jobs, stages, failed tasks, and event timeline tabs. Identify the exact stage, task, executor, and partition. If you start here, you can isolate the exact piece of the puzzle that's acting up. For example, you might see stage 12, task 487 is failing on attempt 1, then attempt 2, then attempt 3. Boom, now you know exactly where to look. And this brings us to the real turning point of the investigation. The executor logs usually reveal the actual exception, and that exception completely determines your investigation direction. Once you know which executor failed, you read its logs. Whether it throws a null pointer exception, an out-of-memory error, or a FetchFailedException, that specific error code points us straight to our suspects. Which brings us to section 3, the prime suspects. So what's our prime suspect number 1? Data skew. It is absolutely the most common reason for a persistent retry. When data is unevenly distributed, one poor executor gets handed a massive amount of work. It's like giving one person the job of 10. This eventually causes excessive garbage collection, the executor's memory fills up, it crashes, and Spark dutifully tries again on that exact same massive partition. Just take a look at this. We have partition 1 at 120 megabytes, partition 2 at 115, and then partition 999 is a whopping 28 gigabytes. Every retry forces Spark to process that massive 28 gig chunk over and over until it just completely gives up. While the standard partitions breeze through their data in seconds, that one skewed partition just sits there churning. If you sort by duration or input size in the Spark UI, this skewed task will stick out like a sore thumb. Prime suspect number 2 is bad data. Look at this comparison. Row 1 is valid, row 2 is valid, but row 3? It's malformed JSON. If every retry fails at the exact same point with a parser exception, then corrupted data is highly likely your culprit. The executor throws an exception, Spark retries the task, hits that exact same bad record, and fails all over again. It is literally an endless loop caused by just a single dirty row. Our third prime suspect is Executor OutOfMemory. This is caused by large joins, heavy aggregations, or those dreaded commands like collect or group by key that just drain the executor's memory completely. The log will clearly show java.lang.outofmemory error. The executor dies, Spark endlessly retries on new nodes, and those new nodes run out of memory too. Spark UI hints for this include an executor loss message, super high GC time, or heavy memory and disk spell. All right, let's check out section 4, other common causes. A good data detective knows there are always other suspects in the lineup. You've got fetch failed from missing shuffle files, or executor lost from hardware failure, or an exit code 137. Maybe a disk full error. You could have a serialization problem or an external system failure like losing a Kafka or S3 connection. It could even just be a code bug like dividing by zero or infinite user logic causing a heartbeat to stop. Grouping these mentally into infrastructure, code bugs, and external systems will really help you rattle them off confidently in an interview.
Next up, Section 5, Key Metrics to Check. To really prove your case, you have to know exactly which instruments to read in the Spark UI and why they matter. Task duration spots slow tasks. Failed task attempts show repeated failures. Shuffle read or write size points to bottlenecks. Input size helps you spot those skewed partitions we talked about. Spill indicates you don't have enough executor memory, while high GC time suggests major memory pressure. Executor loss count points to infrastructure issues. And of course, the exception stack trace reveals the actual root cause. Memorizing this little cheat sheet allows you to effortlessly pivot from just diagnosing the problem to actually proving it.
Finally, Section 6, the perfect interview answer.
Let's bring it all together into the ultimate closing argument. In the interview, you'd say something like, I would first open the Spark UI to determine whether the entire stage is retrying or just a specific task. Next, I'd examine the executor logs to find the exact exception. Based on the error, I'd investigate common issues like data skew, OM errors, or shuffle fetch failures. Once identified, I'd apply the appropriate fix. Boom! That summary right there proves you can diagnose whether a failure is caused by the app logic, the data itself, or the cluster underneath. So are you ready to use this data detective framework to absolutely ace your next technical interview? Next time a stage keeps retrying, don't panic. Just follow the clues, check your metrics, and keep exploring. But I want to leave you with this final thought. If Spark automatically retries tasks to heal itself, at what point does endless retrying become a flaw in distributed system design rather than a feature? Really think about that as you prep. Thanks for joining this explainer, and good luck in the hot seat.